So attendees, you've heard a lot of things that you might need to answer about data types, standards, reusability, repositories. I'm going to try to model how I go about a data intake interview in a compacted time frame. I would normally take notes and follow up with an email to confirm and get more details. So if you all will listen for some of those keywords, just like you might if you were listening for mesh keywords and subject headings, but in this case, it'll be for data keywords. All right, thanks for letting me do that intro. Can you
Sure.
let me know about your data? What kind of data do you collect?
So we record the activity from the brain of rodents, mice and rats.
Ooh.
So they are biological data. So I myself, I collect different type of data. It could be one photon imaging, where I collect videos of imaging of the brain activity. It's an optical measurement approach. The other measurement that I do, I also implant temperature probes, and I measure the ongoing temperature of the brain or body of the rodents. Another type of things that I do, but I do a bit less than the other two, is recording electrophysiological data, which is probably the biggest data that I use, or at our lab we use. And those are like recording several shanks from, it could be from 64 to hundreds of channels of data, ongoing data.
That would be a lot of data. Hundreds of shanks of electrophysiological data.
Yeah, the sampling rate is 20K or 30K in some cases, and we record sometimes 1 hour, sometimes several hours. Not in my case, but in our lab we have cases where we record overnight. Yeah, it's huge data. It's like we're talking gigabytes.
How do you, so I don't know anything at all about one photon imaging. I can guess what temperature of the brain or body is, and probably even that you're looking at the spinal cord since it's neuroimaging when you're talking about body, but maybe not.
Not at our lab, but
see,
other labs.
Bad guess. Can you tell me anything about what kind of files that goes into, like, is it typically a spreadsheet? Do you do temperature maps, heat maps, literally heat maps of heat?
So basically, when we do recording, we collect the raw data and we save that raw data on NYU Share. So those raw data, for example, for imaging, it's a set of videos. For temperature measurement or electrophysiology, these are just .dat data, which means just kind of text data, which are arranged in a specific way. And yeah, so those are just data points. And then we are going to analyze those data. And then we also create, let's say we use MATLAB mainly, and some people, very small number of people in our lab use Python, but mainly MATLAB. And we create figures, we create, also MATLAB arrays, which also could contain data, and we also save those. And after that, once we create figures, we create also, tailored figures, let's say using Adobe Illustrator, and those we use them for manuscript. But those last ones, I personally put them on my Dropbox, not necessarily on the NYU Share, but the data we usually use NYU Share to collect, to keep the data.
All right, so let me make sure that I'm clear on that. You start out with recording videos that you keep on NYU Share, but that's your raw data that comes with associated text DAT files. But that's
it could
sort
be,
of big, very raw.
so the raw data, it could be either videos for the one photon imaging, or those DAT files that are for other, like electrophysiology, let's say.
Okay, okay.
We can't forget about temperature because that's maybe the smallest file.
Okay,
And
okay.
it very much looks like the data format looks like the electrophysiology data. So let's say we have one photon imaging videos, and there are many, because those are 50-second videos. So we record over 30 minutes. So those are for electrophysiology. For one photon imaging, sorry. For electrophysiology, we have those DAT files, which are also gigabyte, where we record those data points for electrophysiology.
Great. So all of it's in the gigabyte scale, but it sounds like the electrophysiology is going to be like hundreds of gigabytes, maybe. The others sounds like more, 5 gigabytes, 10 gigabytes, but that's all still raw.
Yeah, personally, I don't have 100 gigabytes, but other people in the lab, they do. So mine are limited to, I would say, 10 gigabytes, because I don't record that long, but yeah.
Okay, I get it. So then you take it to analyze in MATLAB. And so the full MATLAB arrays and all of your modeling is in there, except for a few of your colleagues use Python, but mostly not you. Am I right so far?
Yeah, I use MATLAB, and most of us use MATLAB.
All
But
right.
some of our colleagues might use Python as well.
All right. And the MATLAB process goes from the raw data stage all the way through preparing your tailored figures, preparing preliminary figures that might go into the manuscript, but then you also sometimes tailor those figures in a graphics program like Adobe Illustrator. Did I get that right?
Yes. So the transition from raw data to making figures, there is also—
That's where I was going to go next. Thank you.
Yeah, okay. So there are, we format data in a, how to say, downsample the structure in MATLAB, and we detect events, for example, create arrays of those events, and then save those under MATLAB structure, or we downsample the data and for other analysis, and we create arrays of those downsample data, and we save them, those downsample data. Because if we want to work only with raw data all the time, we're going to have issue with RAM and and the computation hours. So it's just not possible practically.
Right. Yeah, absolutely. MATLAB arrays make sense. So can I ask about your documentation process for that then? How you document for maybe new PhD student coming into your lab, or for reproducibility, when you report in your articles. How do you, that downsampling stage,
Basically, the way we do it, we organize MATLAB codes, and then those organized MATLAB codes are defined, are done in a way that you define some certain functions, and those functions do specific things, and then we have codes that also call for those functions. So it's through those MATLAB codes that we have the main documentation. Then there are extra layers of documentation, but I personally am not very good at that.
That's okay.
Yeah, no problem. I'm just saying it, but some other people might be doing a better job, especially when you publish some, let's say, analysis process, then you document it well, and there are many of those. And usually we also use those publish, let's say, processes, and then we change it for ourselves. So yeah, so many of the things might not be the best organization possible, but that's how we do it.
Yeah. Well,
And
reproducible documentation is a journey with no end. We just keep improving a little each time.
yeah, that's true. And I'm a postdoc. I don't have my lab yet, so I haven't invested in that yet because it's more like I have my own small home around myself. But I think once I have hopefully my lab soon, then I will definitely think about like creating structures that like students coming in can actually follow, something like that.
Yes, absolutely. Is there a certain way that you would back up this data? Maybe transforming some of the MATLAB code and functions into text to save separately, or exporting your arrays to CSV. I don't know much about your data type, so arrays could be a
Yeah,
lot of
so
things.
yeah, arrays are usually saved in .m files in MATLAB. So we save those, and I have my backups on NYU Share. Some other people are more conservative. They also keep a copy in hard drives. And I had a colleague who was really conservative, and he was telling me, if you want to be 100% sure, the rule of thumb is to have 4 copies in different places.
Yes,
Yeah,
absolutely. 3
I
copies
don't do
other
that.
than your working copy.
I don't do that. I have everything on NYU Share. I trust NYU Share. I hope nothing bad happens.
NYU Share is very solid infrastructure, so that's
Yeah,
great. It's good that you back up your .m files. In your discipline,
yeah, definitely.
can you tell me anything about, are there places that people are starting to share data? Neuroscience is changing so fast. I feel like there's a million people talking about sharing neuroscience data and not really one place to go. Is there a place
Mhm.
people in your specialty share data, NIH repositories maybe?
There are. I am not fully aware of like what in general people do. We have at our lab our own how to say data space, and yeah. So basically, my advisor, Professor Buzaki, he is very much into sharing data, and he supports that. And also, yeah, recently NIH is very much into it as well, and he definitely supports that approach. So we are open about data. So first of all, if anybody contacts us in general, we are open about it, very open about it. Recently, I would say most of the papers we share the data on that online space. Uh, we are not, I would say, yet at a very good situation, but I think we are somewhere in the middle. We are moving towards that. Some of my lab mates, they are doing a great job. Like there are recent papers. The data is wonderfully arranged and prepared for anyone who wants to use it. And yeah, one of my colleagues actually did that. It's amazing. She even prepared all the codes and everything. So if you wanted to produce whatever she did, it's very neatly done.
Wow.
Yeah, I am, to be honest, I'm not at that level, but my papers, when I have data, I put the data online. So, and I'm totally open to get requests about the data, for the data, about what has been going on. I think it's important, especially because, I mean, in my opinion, but I think also probably it's a good logic to say that our work are paid by the collective resources. So I think we have to, the data is the outcome and that belongs to that collective. So it should be available.
Thank you. I agree. I also appreciate you saying that and thinking that. I'm not actually very good at documenting and organizing my own data. So even though I talk to people about their data, I'm not very good at my own data. So, but yes, if the public is paying, then the public should have within the limits of what's technologically possible, should have the
Absolutely.
access.
I worked also 3 years in the industry, and so I learned that, like, for the company, data is the most important, because when you work there the next year or another time, you might not be there, but the data is there and someone else can go and look at it and probably have some use of it, which is, and it's the ownership of the company. So it's the same for public, let's say, research, as you say.
Yes. Are there any standards in how you structure your MATLAB arrays that sometimes everyone, in some disciplines, some research, everyone has a sort of standard layout for spreadsheets, arrays, quantification processes, and in other ones, it's just however each person has to figure out for themselves. Is there a standard that's emerging in your specialty?
So it's a mixture. I mean, there is nothing fixed in, let's say, in general, in, let's say, distant neuroscience, that our lab is in that field. But in our lab, it's kind of a mixture, meaning that, so we have some, let's say, if you want to analyze electrophysiological data, we have some package of codes that are like the core of the analysis, and they have been developed over time by participation of many grad students and postdocs that have been with my advisor over time. And it's a continuous process of refining that. And we all use those codes, but then we have our own touch on top of it. So that's why I'm saying it's a mixture. So there are many stuff that could be the same structure, because otherwise you cannot use that code. But then you have also extra structure that are just for, let's say, my own application, or my colleague might do it differently, or yeah.
That makes sense. That makes sense.
And then, for example, for one photon imaging, I also use another package, which is not originated from our lab, but another lab. And that is also, let's say, publicly available. I use that package, and it's the same. I use the structure of data that package uses, and then I have my own touch on top of that.
And so that's a MATLAB package from another lab. And is that pretty common that labs share their local analysis packages for taking the raw data, especially with more emerging data collection techniques?
Yeah, if you think your package is good, then you would share it.
Do you know if anyone, so in the R and Python communities, there are groups that archive and preserve those packages. I don't know MATLAB as well. Is there a central place where those shared and published packages are preserved for future use if that lab PI retires and the lab breaks up?
So most labs use GitHub, which is a platform to share code of different type. It's not just MATLAB, it could be anything. And most labs use GitHub.
Good practice.
Yeah.
Okay, so it's mostly shared by GitHub, and that would be a great place to get
Most of the
from.
time, you don't have to. You can have your own website and share it on your own website. But I would say it's kind of like, yeah, it's kind of like the, how to say, the mostly used website, I would say, is GitHub.
Personal website is never good, because then sometimes sooner or later the campus changes, the department changes, website addresses get reorganized, and then no one can find your website anymore.
Yeah, sure.
Do you have any other thoughts on reproducibility and sharing in your discipline, and maybe how things are changing? I know neuroscience is moving really fast. Anything else on how people generally are supporting reproducibility in the journals?
I cannot speak of all people. I have had not pleasant experiences myself. Like I was interested in some results in a paper, and I contacted the first and last author, and I asked some questions. The responses were a bit confusing to me. I mean, I'm not necessarily saying it's wrong or right, but it was confusing to me. And I asked for the data, and they said, we will send you, but I never heard back.
Oh.
Yeah, I think it's a good thing to go towards a position where when you have a paper, you have to put a minimum of data, which, let's say, is the main things that are presented in the figures, I would say, or tables.
Right.
Those should
Yeah.
be available. Then, of course, it's kind of tricky thing, because not all data are the same. Sometimes the volume could be so much, or the work to prepare them could be so much, that is going to be very, very hard. But I think there should be a reasonable, way to share the data, and I think that should be kind of the norm. And I don't know, maybe reviewers can say, or the editors can say, okay, this amount of data is enough. And then again, in my opinion, it shouldn't be very, very strict, because then it can be also a dead end situation and very annoying itself.
Yes.
It should be kind of taking it easy, but also enough data to be acceptable.
That makes a lot of sense. And I think that's a very good balance to hopefully reviewers and editors and everyone will work towards that. Especially, I think it's difficult with animal research because there's so many different options and so many different ways.
Yeah.
Thank you so much for your time. I appreciate it. You can log off now if you'd like. I think we're going to have 5 minutes of asking people to fill out an evaluation survey. Thank you so much, though. I really appreciate it.
You're welcome. Thank you very much. Good luck. Have a good one.
And you.
Thank you.
I hope that some of those pieces you could pull out where he was talking about MATLAB. You do have to know a little bit about some software. I don't know anything about electrophysiology, but some of the pieces that you could maybe catch about MATLAB, about emerging standards, about how they share their code snippets as through GitHub as part of their variable structures. Thanks.
Thank you so much, Nina and Omid, for that great interview. This last portion is very quick. I'm just going to show some resources, and the links are in the slides, which I am posting in the chat again. But just to go over what's available to you outside of this presentation, there's some further resources online already. We have, from the NCDS, we put together a toolkit, which is a guide to all kinds of different facets of the policy, checklists for readiness, and other tools that will help you prepare and talk to researchers and work within your institutions on policy preparedness. There's also a great article, the 10 Simple Rules for Maximizing Recommendations NIH Data Management Sharing Plan, which goes through the basics and a lot of stuff we talked about today, but just in a nice, succinct format. And the link is there for you to check it out. But basically showing all the different steps to go through to achieve policy preparedness. NIH has a lot of resources online. They have a website, sharing.nih.gov. This is where we showed you the repositories earlier, the list of repositories. Check it out. They'll do updates there and send out new information when it's available. So that site is dedicated to these topics. And then we might have mentioned briefly, but there are other resources available from organizations, including DMP Tool, which has a great template for the NIH policy. You can go in, log in for free. If your institution is a member, you'll have it set up in there for you. And you can set up collaborative teams and all kinds of other things in DMP tool. There's also a rubric, so you can go through that to see how data management plans stack up against requirements. And that's available as a PDF download from FASB, and we have the link there as well. So just another way to check through a data management plan. From today, hopefully you got a lot of great information, and from our guests and breakouts, we're able to get some skills under your belts. But basically our takeaways are to take some time to recognize what's in the policy and what's not a requirement in the policy. So we talked about a lot of different stuff, but if you check out the policy itself, it's a pretty easy read to get through. And then they have a whole bunch of supplemental information. So if you're interested in any particular topic, you can usually find some additional information on that. Also consider what you're doing, but also be realistic and acknowledge your limitations. If, for example, you're the only person working on this within your library, you might have some restrictions in place that you would like to share with your supervisor and your library administration. And also, try and communicate with them is the third point. Talk about what you can do and what you can't do, what you could do with more support, and how they can support you and your work. Also, check out those existing resources like the ones we just linked to. There's some working groups on this topic. So if you're interested in volunteering and don't know where to get started to work on this area, please reach out to us and we can put you in touch with them. But basically, there are a lot of groups working on this at different institutions and across institutions. And so connect with them, that's the last point. So develop a community at your institution, at your library, outside of your library, with researchers, and also with people at other institutions working on this. You don't have to work on this alone. It doesn't have to be all on you. So check out what's available to you.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel, or select a video thumbnail to watch another video from the channel.